Welcome back, everyone. Our goal today is to talk about the derivative function. And I'm going to explain in some detail exactly what I mean by derivative function. But to motivate it, I'm going to talk about an exercise we did before and explain how, if when we'd done it before, we had known about the derivative function, it would have made our lives easier. The exercise that I'm talking about was this one. In this exercise, we were given this function, x squared minus 6x plus 10. This was at the beginning of section 3.2. And we were asked to find the equation of the tangent line to this function here at 1, 5, here at 3, 1, and here at 4, 2. It turns out this took quite a bit of work, because this page I'm showing you was only actually the work to handle the equation of the red line. We then did this work to find the equation of the blue line, and then this work to find the equation of the purple line. So all in all, this exercise actually took us quite a while and quite a bit of work. And if you look back at it, actually the things we learned, the things that took the bulk of our effort to find, for example, if you look at this page, were the derivatives themselves. So we found f prime of 4, it was 2. It took us all the way to this point on this page before we got there. So I want to summarize the derivatives that we found. That's there. F prime of 1 is minus 4. F prime of 3 is 0. That's there. And f prime of 4 is 2. That's there. So here's an observation about what's going on here. Basically, I have a machine where I take this input, 1, 3, or 4, and transform it into these outputs, minus 4, or 0, or 2. Okay. And what that's really saying is f prime of x is a machine. And what kind of machine is it? It's a machine that takes as inputs the inputs of f, and as an output gives us the slope of the tangent line at that input. In other words, at the input 1, the slope of the tangent line there is minus 4. At the input 3, the slope of the tangent line there was 0. At the input 4, the slope of the tangent line there was 2. Now, basically what I've just danced around describing is that f prime of x is itself a function. And so this f prime of x, it's a function in all the same good ways that all the functions we're used to are. And so one thing that would be really handy is if we could write f prime of x, the function, in the same way we usually do. That is to give some sort of formula for it, like this x squared minus 6x plus 10. So I'm going to leave this as a question mark, question mark, question mark for now. But I want to think about what this formula might be. And hopefully we'll be able to figure it out. Now, one thing that we often do with functions that helps us understand them is to graph them. So I want to graph these points from the derivative here on a graph. So f prime of 1 is minus 4. I'm going to take the input 1 and the output minus 4. F prime of 3 was 0. Input 3, output 0. F prime of 4 was 2. It's an input of 4 and an output of 2. These 3 dots are everything that we found before. This is all the information about the slopes in this question that we talked about a few videos back. Now, even with my not super to scale drawing, you might be able to guess what the graph of this thing looks like. Namely, it looks kind of like a line. In fact, what line would it be? Well, you can figure out that if a line passes through these 3 points, then it would have to be the line 2x minus 6. And so 2 times 1 minus 6 would be minus 4. 2 times 3 minus 6 would be 0. 2 times 4 minus 6 would be 2. Okay. And so here's my point. If, when we started this problem, where we had to find these three tangent lines, we had already known this formula, it would have saved us an enormous amount of work. It would have saved us all of those pages of algebra. So my goal today is to figure out how we can get this kind of formula. Because once we have this formula, then if someone asks you any other derivatives, then rather than having to go through this whole process all over again, I can actually just plug these inputs into this function. And so I would get that, well, f prime of 10 would be 14. F prime of 16 would be minus 38. F prime of 7 would be 8. And so once you know this formula, you really know the derivative of your function at every point, or you really know the slope of the tangent line for your function at every point. So what I want to go over first is I want to go over how for this function you would get from here straight to here. Okay. So the way we sort of did this was to say, okay, well, I've done this 3 times before. I can guess the pattern. It's probably that. I want to assume we didn't actually already do all of that work. How if we just started from here, could we end up here without taking this detour? So here's what questions in this section are going to look like. We're going to say, use the limit definition of derivative, just like we said before, to find f prime of x if f of x is whatever this is. Okay. And so the new thing here, and the theme of this whole section, is that instead of saying f prime of 4, or f prime of 1, or f prime of minus 2, I'm just saying f prime of x. In other words, we really want the derivative of f at every point given to us in some nice formula. Okay. How are we going to do that? Well, we're going to follow the same 3-step procedure that we followed before. So I'm going to start at the point, so before if there was a number, I would start at the point 4 f of 4. Well, I'm going to start at the point x f of x. And then I'm going to bump that point to the right a little bit. Okay, and then the thing I'm supposed to put here has got to be f of x plus h. I'll do a little simplification first, just to save myself some time. Note this is going to be a little messier because there's 2 variables floating around. There's an x and an h. But we can handle that. If I square x plus h, I'm going to get x squared plus 2xh plus h squared. Then a minus 6x minus 6h plus 10. Okay. And so this will come up here and live in this spot. And so this point here, this is x plus h, comma, f of x plus h. And because there's 2 variables, this is going to be a little bit messier than our previous examples, but it's not going to be so bad. Aside from this one difference, that is the fact that instead of using a number like 4, I used an x here, every other part of this process is exactly the same. So the next thing I said to do was to calculate the average rate of change between these 2 points, okay, which is going to be this minus this, and I'm pre-distributing the minus sign, just so that I don't have to copy this to another line, all divided by, and then x plus h minus x. So, then lots of cancellation happens. So first of all, just like before, because I started with an x and then bumped it over to x plus h minus x, it's always just going to be h. So you can just skip there like we have been doing before if you like. But there's lots of other cancellation here. So there's an x squared and a minus x squared. There's a plus 10 and a minus 10. There's a plus 6x and a minus 6x. And so even though this was horribly messy at this one step, at this next step, it's way nicer. And what should at this point be a very familiar thing happens. Namely, I can factor an h out of the numerator here. And then voila, that h cancels with this h. And I get 2x plus h minus 6. And then what's our very last step? Our very last step is we write, okay, our answer f prime of x is the limit as h goes to 0 of that thing we just found. And that is 2x minus 6. Okay. Notice, why is it 2x minus 6? It's because there's two variables here, x and h, but the only one the limit is concerned with is h. Namely, the limit here is saying, what if h gets near 0? Well, then this term just vanishes, and I'm just left with 2x minus 6. So, yes, this page is a little bit messier because of the x's and h's floating around than the previous pages I showed you. But again, once we've done this once, that is, once we've done this one messy page, then all of these derivatives, all these slopes of tangent lines, they're all free. I can get them just by plugging in whatever point it is I want into my 2x minus 6. Okay, so I want to emphasize what's different about f prime of x from f prime of 4 or f prime of negative 2 or whatever that we've talked about before. Okay. And the key difference, and I'm going to keep using this word, is that instead of being the slope of the tangent line, like f prime of 4 was, instead, f prime of x is really a machine for calculating the slope of the tangent line. And I'm going to, just for emphasis, spell out that there are three different things we have called the derivative at a point. So we have called it the slope of the tangent line. We have called it the instantaneous rate of change. And we've just called it the derivative. And so f prime of x is a machine for calculating all three of these things at any given input. So in particular, I want to emphasize f prime of x is one step removed from each of these three things. It's not the case that f prime of x is the slope of the tangent line. Rather, it's the case that f prime of x is a machine for calculating the slope of the tangent line. It's a machine for calculating the instantaneous rate of change at a given input. Now, that distinction seems a bit abstract, so I want to give an example that I hope will make clear why I'm making this distinction. Okay, so here's the question. If I tell you that for some function f of x, f of 3 is 6, and f prime of x is 4x minus 12. So notably, I haven't told you what the function is, I've just told you its value at 3 and its derivative. Then I'm asking you, what's the equation of the tangent line to f of x at the input x equals 3? And so to answer this question, we need a point on the graph, and we need a slope. Okay. The point, well, the input is 3, and so conveniently that's exactly the one output we know. So this is 3 comma 6. And this formula for the derivative tells me the slope. But it's not the case that this is the slope. Rather, the way I get the slope is by calculating f prime of 3, which I get by plugging 3 into this, exactly as the notation sort of suggests. So this will be 9 times 3 minus 12, which will be 27 minus 12, which will be 15. If you're paying super close attention, you might notice I changed this because it was going to work out to be 0, and I just wanted it to be more exciting. Okay, so what does that tell me? Well, that tells me that the equation of my tangent line looks like y equals 15x plus b. Plugging in 3, 6, that tells me that 6 is equal to 15 times 3 plus b. So b is 6 minus 45, which says that b is minus 39. And so the equation of my tangent line is y equals 15x minus 39. Okay, so here's the machine part. The machine part is that I did not just say the slope is 9x minus 12. I said the slope is that with 3 plugged in, and then I calculated that. Okay, so this is operating the machine, plugging in the 3 and evaluating this and getting 15. Now, I am obligated to point out what happens if you miss this and just shortcut this to saying the derivative is the slope. Then when you went to write out your equation of your tangent line here, you would write y equals 9x minus 12x plus b. Do not do this, by the way. But then you would say, well, that's 9x squared minus 12x plus b. And there is a way that should really leap out at you to see that this cannot possibly be the equation of the tangent line to the graph at this point. Okay. Namely, this isn't even a line, it's a parabola. Okay. Lines have equations that look like y equals mx plus b. Okay. So you should always be writing your tangent line in the form y equals mx plus b. If you can't do that, it's a hint that your tangent line's not actually a line. And so, if you give me a tangent line that's actually a parabola, it's not going to go well for you. So make sure, and I'll emphasize this is the right answer, don't do this. Now I'll emphasize again, the reason why I like this answer is it's y equals number x minus number, and that's what your equation for your tangent line should always look like. I'll wrap up this video here for now, but we'll pick up next time talking about more examples of going through and doing this kind of calculation that we did earlier. That is this f prime of x calculation here, where we went through and ended up getting this 2x minus 6. So I'll go through some more examples of those in the next video. But that's all for now. I'll see you next time.